Welcome back to my channel. So this is a problem from 2019 A-Levels Combined Maths New Syllabus Part A section. It's asking to sketch the graphs of y equals absolute value 4x minus 3 and y equals 3 minus 2 absolute value of x in the same diagram. So when we are dealing with absolute value functions, especially sketching them, the very first thing that we need to do is find the vertex. So if the absolute value function is of this form, so let me write that. So it's of this form, y equals a absolute value of x minus h plus k, then the vertex, the coordinates of the vertex is given by h comma k. H comma k. So let's look at the two absolute value functions. So y equals 4x minus 3, the absolute value of that. So I'm going to call this equation number 1. So let's try to arrange this according to our base function. So I'm going to pull out a 4, and then I'll have 3 over 4, and then I'm going to put a 0 there. So now if you look carefully, this is of the form y equals a absolute value of x minus h plus k. And by visual observation, we can identify the vertex for this equation 1 is going to be 3/4, comma 0. Okay, so this is the vertex is on the x-axis. And then let's look at the second absolute value function, y equals 3 minus 2 absolute value of x. Let me call that equation number 2. Okay, and then again I'm going to rearrange it in that original form. I'll have minus 2 absolute value x. I'm going to subtract a 0. It's not going to do anything. And then I'll have plus 3. And this is again the same form as the base function. So then we can again visually identify the vertex for this second absolute value function is I'll have like 0, comma 3. So the vertex is on the y-axis. For the second function, the vertex is on the y-axis. For the first function, the vertex is on the x-axis. So now let's try to plot, let's try to sketch these two absolute value functions on an xy plot. Okay, now I have the xy coordinate system. I'm going to sketch equation number 1 and equation number 2 on this plot. First, I'm going to look at equation number 1. As you can see, when you look at the x coordinate of the vertex, that gives us the breakpoint where the absolute value function changes. So first, I'm going to look at when x is greater than 3 over 4, which is 0.75. Then equation 1 becomes y equals 4x minus 3. And then I'm going to substitute some x values and then look at the corresponding y value. So then I can sketch the actual absolute value function. So x, I'm going to put a value larger than 0.75, let's say 1. So then the y value will be 1. And I'm going to again put a value larger than 0.75, let's say 1.5, 3 over 2. So when I put 3 over 2, the y value will be 3. Similarly, I'm going to look at the other side. a value less than 0.75. So when x is less than 3 over 4, then our equation will become y equals minus 4x plus 3. Again, I'm going to substitute some values for x and then look at the corresponding y value. Let's start with, for example, 0.5 or 1 half. When we have 1 half, I'll get 1. And then we can also have a value like 1/4. Then I'm going to get a 2 and also 0. Then I'm going to get a 3. So this gives me a range of x values and corresponding y values so that I can go ahead and plot uh, the first absolute value function, y equals absolute value of 4x minus 3. So the vertex, as you can see, is somewhere over here. So I'm now plotting that absolute value function. When x is 1, the y value is 1, so it's over there. So this is like a sketch. You don't need to be 100% correct, like precise. Then when x value is 1.5, it's going to be 3, so approximately somewhere over there. And then I'm going to the other side, 0.5. So that's again somewhere over here, like 1. And then 1/4, it's somewhere around there. And then finally over here. Okay, so that's going to give me our graph. So now I'm going to connect the dots, and let's see. So I'm going to connect the dots now. Let's see. So like that, I'll change the color. And then there's going to be another line. Like that. Okay, so I got the actual absolute value function 1. So then I'll write down this part is y equals 4x minus 3, and this part, that's y equals minus 4x plus 3. I'm done with sketching equation number 1, and now I'm going to look at equation number 2. So the breakpoint is 0. So I'm going to look at a value greater than 0. So for values x greater than 0, our function will have this form: y equals 3 minus 2x. Okay. Again, I'm going to put some values greater than 0, x values, and then look at the corresponding y values. So let's look at x equals 1. When x equals 1, I will have y equals 1. When x equals 2, I will have y equals minus 1. I believe that's more than enough. And then the other side, when x values are less than 0, then we'll have y equals 3 plus 2x. Again, I'm going to look at some x values, plug in x values, and look at the corresponding y values. So when x equals minus 1, which is less than 0, I will have the y value would be just 1. And then when x equals -2, for example, when x equals -2, I will have the y value as -1. Okay, so now I'm ready to plot that. I'll use a different color to plot this. So my vertex is at 0, 3. So it's over there. Um, I'm going to look at values greater than 0. At 1, I will have 1, so that point. And then at 2, it will be -1, so somewhere around over there. So again, this is approximate. And then for values less than 0, minus 1, I'll have 1 again. So somewhere it's going to be around that point. And then over here, so at 2, when x equals -2, I will have -1. So like that. So again, I'm going to connect the dots. So this one is opening downward. So like that. And then the other side. Okay, so I have that absolute value function as well. So let me label them. This one will be y equals 3 minus 2x, and this one will be y equals 3 plus 2x. So that's how you plot the two absolute value functions. That's how you sketch them. Okay, let's look at the second part of this problem. Find all real values of x satisfying the inequality. There are several methods to do this one. I'll show you two methods. The first method is just look at the absolute values. So if you look at absolute value of x, the turning point of the actual function is x equals 0. We call it like breakpoints. So for this one, breakpoint is x equals 0, right? And then 2x, absolute value of 2x minus 3. For this one, breakpoint is going to be x equals 3 over 2. So now we are, so because of those breakpoints, we can, in order to find the real values of x, we are going to assign some intervals. So the first interval would be uh, negative infinity to 0. And then the other interval, these are all open intervals, would be 0 to 3 over 2, between 0 and 3 over 2. And the other interval, everything above 3 over 2. So 3 over 2 to positive infinity. So these are the three ranges. So for each range, what we are trying to do is that we are trying to set up that inequality, this one, and see, the x value, the range of the x values. So let's look at a value for x that is less than 0. X is less than 0. When x is less than 0, 2x minus 3, 2x minus 3 will be minus 2x minus 3. Okay, so that's when x equals x less than 0. And then x will also be minus x. And then we have the other part less than 3. So let's try to simplify this inequality. Minus 2x plus 3 minus x less than 3. So then we'll have minus 3x less than 0, because 3 and 3 cancels out. Okay, so then we'll have x greater than 0. But that's a contradiction, because we are assuming that x is less than 0, but then we get x is greater than 0. So no solutions. We can't find any real values of x that satisfies the inequality in this range. So no solution. Okay, so that's that one. Um, let's look at the other range, that is 0 to 3 over 2. So x is going to be less than 3 over 2 but greater than 0. So during this range, let's again look at um, the two absolute value functions. So here x is larger than 0. So then our the 2x minus 3 absolute value will be the same with a minus sign in front, but the absolute value of x, it will be the opposite. It will be plus x. And this entire thing is less than 3. And then we are again trying to solve this. Minus 2x plus 3 plus x less than 3. So we'll have minus x. And here it's less than 0. Or we'll have x greater than 0. Okay, and that's true. So x greater than 0, because if you look here, x greater than 0, so that is valid. So this is valid. Then the other range, the last range, values greater than 3 over 2. So I'm going to have the range x greater than 3 over 2. And then I'm going to look at again the absolute values. So 2x minus 3, absolute value of 2x minus 3. So that will be just plus 2x minus 3. And then absolute value of x will be just x. And this is again less than 3. So I'll have 2x plus x, 3x, minus 3 less than 3. So 3x less than 6. And this will give us x is going to be less than 2. And you can see x value should be greater than 1.5 or 3 over 2. And this is right. X is less than 2. So this is valid. Now, the last two regions, we can combine the two, and we can have something like this. So x value will be greater than 0, and then x value is going to be less than 2. So we can combine these two, we can find the union of these two. So then the real real values of x that satisfy the inequality will be the union of these two, which means x value is going to be between 0 and 2. Okay, so that's the answer for the second part. So the real number values of x that satisfy the inequality is any x value between 0 and 2. There's another way to show this, and let's look at that way. Okay, this is the other way. So it's a graphical method. I have basically sketched the two functions. So this is the inequality, 2x minus 3, the absolute value, plus absolute value of x. That's less than 3. I could rearrange this absolute value of 2x minus 3 less than 3 minus absolute value of x. So I'm going to plot 2x minus 3 absolute value. So that's my equation 1. And 3 minus absolute value of x, that's my equation 2. And then I have plotted those two functions here below. The blue line shows uh, the blue line shows the first equation, and the red line shows the second equation. So here you can see we want to satisfy the second equation is going to be larger than the first equation. What's that range? And you can clearly see that range here according to you have this point, so that's 0 comma 3, so the x value is 3 over there, and then this point, so that's where you have, so this is this 3 minus absolute value of x, and this one, that blue one, is absolute value of 2x minus 3. So equation 2 is always larger than equation 1 for this region. So let me use a different color to show you that region. So this part, for that part. And then we need to find what are the x values. So the x is 0, right? You know that's that point, 0 comma 3, and then this x value, and that's obvious to you, so that's going to be the x value would be 2, the y value will be 1. So here again, looking simply by observation, you can find the real uh, values of x that satisfies the inequality, which is again any x value between 0 and 2. So that's the other way of getting the answer. It's simply by observing, the larger absolute value function than the smaller absolute value function for that inequality. So this is the second method. It's much more easier. You have to just sketch the two graphs.